Hi AP Stats students. Today we're going to go through two sample t-tests for mu1 minus mu2. Quick review. Just remember, I do go fast through this because I'm not teaching it to you for the first time. We're just reviewing for that AP exam. I'm also going to have some other problems up. I'm not going to go through them after this, but I'm going to talk about the wording and what to look for. A lot of you asked that on the survey that I gave you. Can we go through just the wording and what to do when it says this, so on and so forth, and just looking at more AP problems. So first priority is to get through this slide. If you need to take a break, that's fine after this slide. But then I would say another priority or even a requirement or it's mandatory would be watching the rest of the video because I'm going to address a lot of those concerns. How do I know what to do when they say a certain phrase, so on and so forth? Okay, so let's get going with this two sample t-test for mu1 minus mu2. Hold this up here. A large pet store buys the identical species of adult tropical fish from two different suppliers, Buy Right Pets and Fish Friends. Several of the managers at the pet store suspect the lengths of the fish from Fish Friends are consistently greater than the lengths of the fish from Buy Right Pets. So we think Fish Friends are greater than Buy Right Pets. Random samples of 8 adult fish species from Buy Right Pets and 10 adult fish of the same species from Fish Friends were selected, and the lengths of the fish in inches were recorded as shown in the table below. Here we go, okay? So you can see that we have our data here, okay? And then we have our statistics, which is kind of nice. That can eliminate a step for us, possibly. I'll talk about that here in a second. Do the data provide convincing evidence that the mean length of adult fish of the species from Fish Friends is greater than the mean length of the adult fish from the same species from Buy Right Pets? Okay, so here's the first thing I'm going to highlight. Do the data provide convincing evidence? It says nothing about a significance test. It says nothing about a hypothesis test. But it also doesn't say anything about an interval, okay? So one phrase, and I'll try to type this all up for you as well, but I think it's good for you to listen to it and really analyze it as I'm saying. When it says, do the data provide convincing evidence, that's a test. That's a significance test, a hypothesis test, same thing, okay? If they're asking about evidence at all, you're doing a test unless it states construct an interval. Okay, so that the mean length of adult fish of the species is greater than the mean length of the adult fish of the same species from Buy Right Pets. We're off to our state. Plan do conclude. In our state, we need our parameters. We have two parameters, mu1, mu2. We need our null hypothesis, our alternative hypothesis, and our alpha. Now, how do I know how to set up mu1 and mu2? It really doesn't make a huge difference as long as you go about it the right way. But I personally think it's important to read the problem. So it says Fish Friends first is greater than Buy Rights. I think it's easier if you set it up that way. So I set my mu up to be about Fish Friends. So mu1 is the true mean length of the adult fish from Fish Friends. So I put FF for Fish Friends, okay? On the exam, I probably would write out Fish Friends. I'm just trying to save you guys a tiny bit of time here. Mu2 then would be the true mean length of adult fish from the same species from Buy Right Pets. Okay. Again, just a friendly reminder: your mu is always the true mean. Some people are wondering, how do I know if it's mu? How do I know if it's a p? Okay. We know it's a mu. Well, they talk about the mean in here. It's also quantitative data. There's nothing about proportions in here. Okay. We also need our null and our alternative. We always assume they're the same, okay? And then we want to see either is one greater, less than, or not equal to, and they tell us it's greater than. So here is my mu1 is equal to mu2, and then we're trying to prove that mu1 is greater than mu2 with an alpha of 0.05, okay? What's an alpha again? An alpha is that significance level, that little fish right there, okay? All right, the plan. We need to RIN twice. I talked about this in yesterday's video as well, where we had that R, that I, that N. In class, I always have that graphic organizer, right? So that was just like a reminder that you have to RIN twice. But more importantly than RINing twice is it had this third arrow coming off of it, meaning the two groups are independent of each other. So let's run twice. R is for random. Is there a random sample? And I believe it is stated random samples of 8 and random samples of 10. There we go. Okay, so we put random samples of N1 is 10 and N2 is 8. Now, here's the catch where some of you might get this flipped around. It says in the problem, and I think this is confusing, it says 8 first and then 10. Just remember, you said mu1 was fish friends. So that's why I put N is 10 first. And maybe like what they did, I kind of like what they did there, NF for the sample size for the fish friends versus the sample size for the Byrite. That might be another thing you could do as well, just for organization. Okay, next our independence. That again is a friendly reminder. Is your 10 N is less than capital N, okay? And then again, you should have checked back in other videos. This R and this I changes if it's an experiment. So just a friendly reminder about that to check back or ask if you still have questions about that. We're not doing an experiment right now, so we're sticking to this 10N is less than capital N. Now, that's our I right here, so we can't forget about that third arrow, right? That looks sloppy, I'm sorry, okay? So I have 10 times 10, because that's my sample size from fish friends, is less than all fish from fish friends, okay? And then my sample size from Byrite is 8. So I say 10 times 8 is less than all fish from Byrite pets, okay? Finally, my N, okay? My N has to be greater than, for this condition here, my N has to be greater than or equal to 30. It clearly isn't, okay? And so I typed it out just in case some of you are going to choose to type on the test how you would write that. So N is not greater than or equal to 30, okay? Because I know some of you might choose to do that. So I want to make sure you're aware of just how you type some things in. Okay, I think we're good there. State, plan. Oh, we're missing something. The method. How many samples do I have? 2. Am I dealing with a T or a Z? A T. How do I know it's a T? Because we're dealing with means. 2 sample T. Am I doing a test or an interval? A test. How do I know? Doesn't ask for an interval. Test 4. I have 2 mu's and I'm looking at the difference. So I have a 2 sample T test for mu1 minus mu2. Okay. And again, that's how you write mu if you're typing. You put mu. Okay, next I'm going to draw the curve. Okay, so really all you need for the AP is that T-score, the degrees of freedom, and the p-value. A lot of you guys like the curve. A lot of you guys like drawing it. Now, if you're going to type it, obviously you don't have to, but maybe if you're going to type it, I would suggest even drawing the curve just to keep your mind straight on a piece of paper, just to get everything kind of set up for you so you don't make any mistakes. Okay, so let's go to that curve. So I drew it out. I have my curve, and in the center, I have my parameter. And what do I know about my parameter? I assume that they are the same. And this curve is describing the difference between mu1 minus mu2, right? So this curve is describing that sampling distribution. 0 is the center. Now the standard deviation, how do I remember how to get there? I go to my favorite page, you guys. My favorite page is right here. I have 2 samples. I'm dealing with means. Here's my standard deviation. I showed you how to type that yesterday. Today, I'm just writing it out. Just be careful. Yesterday, remember, I forgot to put that square root, and you type out SQRT for square root of that, okay? Just watch yesterday. I corrected it and everything, so it should be fine. Okay, so now back to the problem. So I took that standard deviation. Now remember, you're taking it from the fish friends first. 0.55 over 10 plus 0.434 over 8. And you have to square both of those as you see on the formula right here. Okay. Now, does it matter if you reverse those? No, because it's addition just by order of operations. It wouldn't matter. I just like to keep things organized the way in my eyes they should be. Okay. Now I have an observation, right? I have 2 X bars and I'm going to subtract them. Well, how do I know which one to subtract first? mu1 is my fish friend. So I'm going to take X bar of 1 first minus X bar of 2. So 3.46 minus 3.40. And that gives me 0.06 right here. And I'm looking for this area. It is only one-sided, okay? That means it's a greater than problem or it's a less than problem. It is not a not equal to, where we'd shade on the other side as well. Deep breath. Let's summarize what we just did. We set up the curve. 0 goes in the center. We look at our statistics, our X bars. We subtract them. We mark where that is. We mark our standard deviation, and now we're set up for not zoms, but toms. T is equal to our observation, 0.06, minus my mean, 0, divided by my standard deviation, okay? And now I'm gonna go to my fanciness to do all this. Now I can write it out first, okay? So T is equal to 0.06 toms, my observation. This is what I observed, the difference between those two X bars, minus my mean, the center, divided by my standard deviation. Okay, now because my mind's always on the next thing, you guys know that about me from class, I jumped over something that I wanted to show you on the calculator. We need to go back to this condition here. And forgive me, I hope for those of you who are so linear, you can't handle kind of going back very well, that it kind of messes with you. I really am sorry, okay? So we do know that normal condition, that 10 is not greater than or equal to 30, and it has to be greater than or equal to 30. Why do we know that? Based off the central limit theorem, okay? So what do? What we have to do is we have to graph it, and I've talked about this several times. If it's a medium sample, okay, it needs to be, it can be a little bit skewed, but no outliers. If it's a small sample, okay, it should be pretty symmetric for the most part, no outliers. So you could, if you want to draw a quick dot plot, okay, or you're going to go to your graphing calculator. And because, oh no, I'm going to run out of battery. Give me a second. Okay, so I'm going to go to my calculator because I want to address this just in case something comes up where they don't give you the statistics. So here they were nice and they gave you the statistics too. I think that's a little bit easier. Then I don't have to type in the data in my calculator. But we need to get a graph of this anyway. So I'm just going to kind of do both here for you. So what am I doing right now? I am addressing that n is not greater than or equal to 30, and it needs to be. But the t distribution is robust. So we can go on if it fits our parameters here of what we need. Stat, edit, okay? What I have here is in L1, I have all the data from Fish Friends. In L2, I have all the data from Buy Right Pets. I am gonna double check. It takes just a couple seconds to double check, you guys. Don't make that mistake on the AP exam where you don't double check and then you go and do everything right based off some wrong data. Okay, double check. And now I'm going to go through and I'm going to hit second y equals. I'm going to enter on plot 1. And first what I want to look at is I want to look at a box plot of just L1. Okay, why am I doing this again? N was not greater than or equal to 30, and it didn't say it came from a normal distribution. So I'm going to go to Zoom. I'm going to go to Zoom Stat. And because I teach Algebra 2, I have another graph in there, forgive me, okay? And now we can make an argument that that is pretty symmetric. So you are going to have to somehow sketch that or somehow import that picture. Now, and I don't know how that's going to look, you guys. So we'll run with that. We'll go with that. You might have to, if you're going to type everything out, right? I don't know if you could type and also upload. I'm going to have to look into that more. There's been so many videos that have been coming my way for this year's test 2020 that I don't know. The biggest thing that we should get right now though is, hey, we know how to do that state. And right now I'm talking about that plan, okay? That plan where n is not greater than or equal to 30. I have a graph right here. It is symmetric enough with no outliers. So we're okay to proceed for N1, for Fish Friends. Let's now look at the of the box plot for Buy Right Pets. So I'm going to go to second y equals, plot 1 on. I'm going to change this to L2. Okay, I'm going to go to Zoom 9. And that looks so symmetric, right? So on the test, if you're writing this for this year for 2020, I'm really hoping they give you the graphs already of these so you can say, look at the graph above. But if they don't, you guys, if they don't give you this graph, okay, you can trace and you can do a quick box plot. Just quickly sketch that box plot. Okay. Could you do something else too? Yes, you could do a dot plot, so on and so forth. Okay, I'm kicking myself that I went just a little too fast for you there, but we're going to keep cruising and I'm going to trust that you guys are good. Okay, because we've learned this before, right? This is not your first time learning it. State our mu1, our mu2, it's equal to, it's greater than, okay, our alpha. We have random samples of both. We did our 10n is less than capital N for both. And then we said the fish are independent of each other. I probably should have put fish from both stars are independent of each other to make it a little stronger. 10 is not greater than or equal to 30. We need it to be greater than or equal to 30, okay? So what we would do is we would sketch those box plots and say, and you would do this properly, and I've talked about that in class. I'm just trying to save you guys a little time. You would label it, and you would state both box plots are pretty symmetric with no outliers. Then you're okay to proceed. You have to do this. You must do that. Again, I'm crossing my fingers for you that they will give you the graphs of these, okay? So you can just state the graphs above are symmetric with no outliers. Deep breath. We're getting there, you guys. You're doing great. Okay. So we've already set up our curve and we've talked about why everything is where it goes. We've talked about where the formula comes from, why we have 0.06 there because we're taking our two statistics, our X bars, and subtracting them. And then we're ready to go to the T. We have everything in our calculator. And now I'm going to go to stat. I'm going to arrow over to tests and I'm going to go to 2 sample t-tests. That's number 4. Now I have the data in already, but if you do a dot plot on your own and you don't enter the data in L1 or L2, you can go to right to statistics. That's so much faster. Okay. That is so much faster. So I'm going to go over and either way, because this data comes from both, I'll go back to the data because that's just where I was. I have my list 1 L1, list 2 L2. Okay. And I have a greater than alternative hypothesis. I am not going to pool. And I'm going to go down and I'm going to calculate. And those frequencies should always be staying at 1. And here we go. We have our t-score. We have our p-value right here. We have our degrees of freedom. And then we have the other data that we know about this. I'm going to use my fanciness so we can look at that screen over here. Okay, so what do I need to put on that AP test? Then I need to say that that t-score is equal to 0.2586. I have recently found that some people don't know how to round. We're rounding to that 4th decimal place. We look at the 5th. If it's 5 or above, you need to round up. If it's below 5, you keep it. So we're going to round up. 2586. I have my t-score. I have my p-value. Of 0.3996. And now I'm ready to conclude. And what is the College Board looking for in their conclusion? Okay, the first sentence is about the p-value compared to the alpha, and if you reject or fail to reject the null hypothesis. Remember, when the p-value is low, reject the HO. The second sentence is about the HA in context. You either have evidence or don't have evidence for HA, okay? So I'm going to say because the p-value is greater than alpha, I fail to reject the null hypothesis. I do not have evidence, okay? Now again, some people struggle with the context. I'm going to go right here. I do not have evidence that the true mean length of the adult fish from the species from Fish from Friends is greater than the true mean length of adult fish of the same species from By Right Pets. Okay. from fish from friends is greater than the true mean fish length of the same species from Bi-Rights. Okay, now what's going to happen is if you want to take a quick little break, do what you need to do. This suffices right now for what is a true sample t-test. Again, I went fast because I'm not teaching it for the first time. I'm just talked about a couple things. State, plan, do, conclude. What I'm going to do next is I have, I think, 3 or 4 more examples. I'm just going to read through it with you. I've highlighted some things because really the College Board every year changes how they ask the questions just a little bit. So you want to make sure you're prepared for what there's asking. And my favorite part about these questions that I've picked for you guys is in those parts, they also have some review in there as well. So I'm going to talk about some review as well. Okay. We'll see you in 2 minutes or whenever your break is needed. Okay. So come on back at the 21 mark. Okay. So I hope you had a good little break. So the goal of this last part is to look at just, and you can see I have things highlighted here, looking at how were questions read? What should I do? What should I execute? Because if they say, do you have convincing evidence? One year I had someone say yes, and that was it. And that person got a 2 on the exam because they did very well in the multiple choice, but did not do so well on that free response. Yes is never an answer. Okay, we need to be doing some work here. So sleep researchers know that people are early birds that prefer to go to bed by 10 p.m. and rise at 7 a.m. While others are night owls, that's me, okay, preferring to go to bed after 11 p.m. and rise after 8 a.m. A study was done to compare dream recall for early birds and night owls. 100 people of each of the 2 types were selected at random and asked to record their dreams for 1 week. Some of the results are presented below. The researchers believe that the night owls may have better dream recall than do early birds. One parameter of interest is to the researchers is the mean number of dreams recalled per week, where we have mu of E representing the mean for the early birds and mu of N representing the mean for night owls. The appropriate hypotheses would be HO is mu of E minus mu of N is equal to 0. Now, real quick, I know you're not used to that. We do ours like this. Mu E or mu of 1 is equal to mu of N, okay? Now, don't panic if you see something like this on the test. Just use simple algebra and you could think if I add this to the other side, that's what we normally do. Same thing here, right? We add this to the other side. I get mu of E is less than mu of N. Now, some people may be panicking because they're saying, hey, do night owls have better dream recall? But I see a less than. That makes sense though, guys, right? Because this is going to be bigger. That's what we're trying to figure out. If this is bigger, and this is smaller, okay? Which means if this is bigger, I'm gonna get a negative number when I do E minus N, which will be less than 0, okay? So just a real quick describing that. If you have questions, let me know. Here comes the actual question now. State 2 other pairs of hypotheses that might be used to test the researcher's belief. Be sure to define the parameter of interest in each case, okay? So what is this question getting at? This question is getting at, can you read the table and come up with some other ways we could do the state step, right? And I'm actually going to go through this one with you. I'm not going to do the whole thing, but I am going to do part A. So what I'm going to look at is, okay, I have mean here. I know that's a t-test. I have the median and the standard deviation. I've never learned tests with those. I don't know, is it a Z or a T or what to do? But I do have proportions here, and I have learned things about proportions, okay? So one thing you could do, and I won't do all of it, but you could start here the proportion who recalled no dreams, right? So you could say P of 1 equals the true proportion of people who recalled no dreams, right? And then P of 2 would be the true proportion of people who recalled, who recalled no dreams in the early birds group. Okay, and then recalled no dreams in the night owls group. Okay, and then our HO, right, would be P of 1 is equal to P of 2. And then our HA, okay, what are we interested in? We think that the night owls might recall more, right? Okay, so that means no, for the no dreams here though, okay, so for the no dreams, how would we set that up? Okay, so we're gonna actually say that in this case, the early birds, if the night owls recall more, the earlier birds recall less if we're trying to prove that. So in this case, we are wanting the early birds to have a higher percentage of people who recall no dreams, which would make us have evidence that the night owls recall more, kind of. That makes sense. Hopefully that makes sense to you. Oopsie. And again, I'm talking fast because we're reviewing. I'm not teaching it for the first time. So that's why it's really up to you to write down and say, hey, Miss Opal, at the 25th minute, I really didn't understand part A. Can you maybe just do a little video and go slower through it? And I'll certainly do that. I don't mind doing that at all. Okay. My kids might. They're getting sick of me making videos, I think. But my daughter's going, yep, yep. But I don't. I like making videos. I feel more connected with you guys that way. Okay. Okay, so that's one way you could do it. Then another way you could do the ones who recall 5 or more dreams. So I'm not going to type this one out. Let's just talk about how it would change. P1 would be the true proportion of people who recalled 5 or more dreams in the early bird group, and the true proportion of people who recalled 5 or more dreams in the night owl group. This would stay the same. I don't know why I put P2 there because I'm going too fast. Now this would be different, right? Because we're curious that the night owls recall more dreams. So that means the early birds would recall less dreams. So that would be a less than, like that. Part A done. Now use the data to carry out a test of hypotheses about the mean number of dreams recalled per week given in the statement, part A. Do the data support the researcher's belief? Let me just move this. Okay, there. Okay, again, this is worded different. The one thing you need to know, do the data, or use the data to carry out a test of hypothesis. So they tell you there that you're doing a test. Then what they tell you next is about the mean. So you're dealing with these numbers here. Okay, since it's about a mean, you're using a 2-sample t-test for mu1 minus mu2. Okay, mu1 minus mu2. Okay, next, do the data support the researcher's belief? This again is not a question of saying yes. You're carrying out a test, a state, a plan, a do, a conclude. And guess what? The conclude is talking about data supporting the researcher's belief. So as long as you conclude, you have answered this question. Okay, I wanted to talk about here, just this one here, because it's a little bit different with all this data that's given, and reading that table and making sure you understand that table. And then I wanted to talk about part B because it asks you to do a test a little bit different than it did over here. Here it said, do the data provide convincing evidence? Let's cruise through the next ones. Do the data provide evidence? Perform an appropriate test at alpha equals 0.10. Perfect. Do the data provide evidence? We're doing a test. We are not doing an interval. How do I need to know about what test I'm going to do in part A without even reading through this whole problem? I'm going to look and I'm going to say that the mean number and the mean number, so the mean number of classes in September of 1990 versus September of 2000. And they give us that alpha there. That's a big yes. Okay, if they don't give us an alpha, we talked about what that is. That's 0.05. So again, what am I doing right here? I'm just showing you different ways that are going to ask you questions on the test based off of questions that have been written by the College Board. Okay, again, I don't need to read through this whole problem. Let's just go to the problem, the question right here. Does the new drug appear to be more effective than the standard treatment in lowering the mean cholesterol level? Don't just say yes. You're doing a test here. How do I know I'm doing a test? Give appropriate statistical evidence to support your conclusion. So what have we seen when they ask you for a test? Right now, we've seen 3 different ways, I believe. Do the data provide convincing evidence? Use the data to carry out a test of the hypothesis. Do the data provide evidence? Perform an appropriate statistical test. And does the new drug appear to be more effective? Give appropriate statistical evidence to support your conclusion. All of these different ways just to get a 2-sample t-test for mu1 minus mu2 from you. Let's keep cruising. This one is a review question. Okay, I'm going to talk about some review things in here. A researcher thinks that the modern Thai dogs may be descendants of golden jackals. A random sample of 16 animals, 16 animals was collected from each of the 2 populations. The length in millimeters of the mandible, jawbone, was measured for each animal. The lower quartile, median, upper quartile for each sample are shown in the table below, along with all the values below the lower quartile and all the values above the upper quartile. Display parallel box plots of the mandible lengths, showing outliers, if any, for the modern Thai dogs and the golden jackals of the grid below. I've reviewed with you how to make a box plot. If you need a separate video, that is your job as an AP student to reach out to me. What I did is I went about and I just showed the work right here. So if you want to pause your screen and take a snapshot of it, just to make sure you remember how to get that upper bound, okay? And the lower bound. So that's that outlier rule, okay? Quartile 1 minus 1.5 times the IQR, and quartile 3 plus 1.5 times the IQR. And then we have this lower fence right here, and we have this upper fence, right? And then we look at the data that they gave us, and you look and you see, is there any data outside that lower fence or that upper fence? So here's our values below the quartile 1. So you can see all the way down to the minimum value. And then you can see all the way up to the maximum value to tell you if there's outliers. So there's no outliers for that Thai dog, okay? Because 138.5 is our upper, and there's nothing above 138.5. And 110.5 is our lower. And there's nothing below 110.5 here, okay? So no outliers. Then we have our golden jackals, okay? So again, we take our outliers because they gave us all this information up here, okay? And I don't want to go through this all with you. I just want to quickly review. We do the same thing. We get a lower fence and we get an upper fence. And we do see that we have 3 upper outliers, okay? So our upper fence was 119.5. So I go up and I'm like, oh, I have these 3 are all upper outliers. So I make my box plot and I show you here. And this is a modified box plot. So we have 3 little stars. Now, just a friendly reminder, how do I get to this plot right here? So I would make now the tail goes to 114, my next maximum one. And again, this is review right now. So if you're like, what the heck is she talking about? You have to reach out to me. I don't mind. And don't be embarrassed. Okay. It's not a big deal, but I'm not going to spend this time to just teach specifically how to make that box plot. I'm just reviewing. What I really want to talk about now is the writing of a few sentences comparing the distributions. Whenever you're writing about a distribution, that's SOCS, okay? Or SUDS. SUDS is for regression. SOCS is if you have univariate data. That it means you have one variable, a box plot, a histogram, a stem plot, okay? And we have 2 different box plots coming from a variable about Thai dogs, that's one variable, and a variable about golden jackals, that's the other variable. But it's not a scatter plot, right? Comparing the 2 that way. So you need to use SOCS, okay? And the biggest thing, don't lose credit on this, is you have to have comparison words, okay? So they have the answer right here. The distribution of mandible lengths for modern Thai dogs and golden jackals are not similar. I don't think you need that sentence there personally to get credit. The distribution of mandible lengths for modern Thai dogs is approximately symmetric. And the typical value is about 125. Whereas the distribution of mandible lengths of golden jackals has a typical value that is much smaller, okay? Around 108. And the distribution appears to be skewed to the right with outliers, okay? How do I know it's skewed to the right? You look at this side from the median, this side all the way out to my maximum is much longer. That means we have a tail than this side over here to my minimum, okay? They phrased it a little bit different than I would have. I would have said the distributions of the modern tie dog versus the golden jackal. The modern tie dog is pretty much symmetric. The golden jackal is skewed to the right, okay? The median of the golden jackal is smaller than the median of the modern tie dog. Shape. I've talked about center now. Outliers. There are 3 outliers for the golden jackal. There are none for the modern tie dog. Finally, the spread. I'm going to look at the quartiles when I'm given a box plot. Okay. And you can look at the picture here. The quartiles, right? So I would say the variable in length is roughly the same for both types of dogs. I personally would calculate it. You can see the IQR right here. I wouldn't say it's the same. I would say because I have that quartile 3 and that quartile 1 and quartile 3, I would actually find it. And I found it here. That's 7. I've already done that. So it's not any extra work for you. So I personally, just because I know some of you are going to want this, I would state, okay, the distribution of modern tie dog is symmetric with no outliers, whereas the distribution of golden jackals is skewed right with 3 outliers. Okay, the mean or the median of the golden jackal is, what do we say? Smaller than the median of the modern tie dog. The IQR of the golden jackal is smaller than the IQR of the modern tie dog. You would get full credit for that. AP, when they do their responses, I think sometimes they give a little too much when they're talking to juniors and seniors in high school. Okay. All right, next. The goal of that part A was to just quickly review with you box plots and a big thing. And every year I predicted it will be, I don't know for 2020, but usually every year there's some sort of comparison question. So just remembering socks, okay, and using those comparison words. Part B, is it reasonable to use the sample of mandible lengths of modern tie dogs to construct an interval estimate of the mean mandible length for the population of modern tie dogs? Justify your answer. No, you do not have to compute the interval. When they're asking, is it reasonable? They're asking about the do step. Go through all of the conditions, okay? That's what they're asking for in this one. Part C, is it reasonable to use the sample data of mandible lengths of the modern tie dogs and the sample data of the mandible lengths of golden jackals to perform a 2-sample t-test for the difference, okay? In this case, again, they're asking for the conditions. And what you're going to state in this one is no, you can't. Why is that? Because we have outliers in the golden jackal. So we can't go about that. Our conditions are not met for that one. In part B, the conditions are met. If you talk about the randomness, independence, symmetric enough, yeah, it would be okay. All right, let's see. Do I have anything else for you? Oh, are you guys so sick of it? Oh, I have a lot more. You know what I'm going to do? I'm going to stop and I'll make another video of this a little bit later. We'll stop right here, but I do think it's important to be looking at this stuff. So 40 minutes, you had 20 minutes, break 20 minutes. I know it's a lot, but your test is coming up and I'll just make sure that you guys watch this over, a couple days. So you guys take care. Stay safe. I miss you guys.